Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. So I'm really excited to have Ian Foo. He's the CTO and EVP of products for CyberRatings. And today, I believe we're going to cover some fascinating topics around cybersecurity, like what is SASE, what is an exploit, an evasion, or malware, and why is it so important to be protected against this landscape? These threat landscapes are getting worse and worse. So with that, I'm so excited. Ian, if you can just share a little bit about your background and CyberRatings background, that'd be appreciated.
Sure. Hi, Pascal. Thanks for having us. It's a pleasure to be here. So let's start with that background. CyberRatings operates typically under cyberratings.org, which is our website. And we're a nonprofit 501c6 organization. We're dedicated to testing, evaluating, and validating cybersecurity products, services, and technologies for the industry. We perform that testing and we use that data to help enterprises, service providers, government agencies, and other entities and organizations improve their governance and make informed decisions around cybersecurity technologies by providing this independent third-party security effectiveness assessment perspective, if you will. In doing all of this, we conduct two types or categories of testing. We perform what we call public testing, which is generally organized into groups of vendors and technology categories, which is actually executed for free. We don't charge vendors for that. And typically what we do is we publish the results to the public and to end users. And we also perform private testing, which is more focused engagements with partners, vendors, and enterprise customers to perform testing around specific requirements, which aligns with what we're doing with MEF, if you will. But ultimately, our mission at CyberRatings is really to help foster and bring more transparency into the cybersecurity industry and market to drive improvements in security effectiveness across technology areas, product areas, like firewalls, SASE, SSE, other security solutions, and security adjacent technologies, emergent technologies like artificial intelligence and quantum computing.
What about yourself, Ian? I understand that you came from Google?
That's correct. So yes, I've been in the industry for quite a while. My most recent role prior to joining CyberRatings was at Google Cloud, working on the cloud networking and network security side of things. Prior to that, my career brings me back through the networking industry, really, starting off as a network engineer back in the days of AS1 for a company called Bolt Beranek Newman. And for some of the internet historians out there, they'll recognize the name as the DARPA contractor that basically built ARPANET for the government, which eventually evolved to the internet. After my time at BBN at the beginning of my career, I spent about a dozen years at Cisco on networking and network security, and some time at Huawei, interestingly enough, another large technology provider based out of China to help foster network technologies and security there. And eventually making my way to Google and then landing here at CyberRatings.
Well, fascinating background. Thank you, Ian. So, before we get into this episode of cybersecurity and certifications and SASE, what can you tell us about what's going on in this cybercrime space? Where every state-sponsored nation is out there that is basically bringing in lots of cyber threats. So, do you have any kind of update you can give our listeners?
Sure. It's interesting. If you look at the stats on cybersecurity and threats in the cybersecurity landscape, the impact of cybersecurity events and attacks, the impact of it financially is increasing. The frequency as well as increasing. The types of attacks are slightly morphing. But yes, the stuff that's making into the headlines that everyone sees is we see more aggressive threat actors driven by nation states or sponsored by nation states. I guess in terms of trying to advance geopolitical policies, if you will. And then there's still the criminal side of it, which is growing at a rapid pace that a lot of people hear about once in a while, but don't understand how large of a market it is, in terms of breaches that lead to ransomware and ransomware leading to ransom payments. We're talking about, billions and billions of dollars being exchanged at a criminal level. And some of those criminal organizations are also affiliated with some of these nation states that you may hear about. We heard recently about Bitcoin thefts, in the $1 billion range, right? And so the impact financially is growing at an incredible pace. And the strange thing is that, security spending and security technology spending is also growing, but not at the same pace that the impact of these threats is hitting the industry, right? So we see that although spending is increasing, the impact is disproportionately higher than what we see in terms of adoption and deployment of security technologies.
Now, when we think of this, we think of it from an IT point of view of threats affecting our systems and information technology. But what about operational technology? We've not really seen our grids go down or our pipelines go down or airports go down from operational technologies. Or maybe it has and they've not been publicized. Have you ever heard of operational technology going down? I know we had that pipeline for a while, but that was not considered operational. It was considered IT back then.
Yeah, OT systems do get impacted. I think the critical infrastructure ones, to a certain extent, if they are impacted, I don't believe we would largely hear about that, and rightfully so. I think, depending on how it's positioned, I'm not sure that the average person would understand the impact, and unjustifiable panic might ensue, right? So I think that as people are dealing with those, they may be happening behind the scenes and probably just not brought to light. But there are some incidences that are making their way into the news. There was a recent article about how IP-connected cameras have been leveraged as sources of traffic that are encrypted to bypass EDR systems on endpoints or endpoint detection and response systems, protecting particular endpoints. So I think that threat actors are becoming much more sophisticated in how they can leverage OT systems, not just in attacking the OT systems themselves, like the pipeline monitoring sensors and systems that you mentioned earlier, but actually leveraging things like IP-enabled cameras, which fall in the OT space, to become jump points or agents of attacks on other infrastructure.
Yeah, and I think, what many don't realize how critical this is, that basically our lives are now dictated by computer informations and technologies. And if that goes down, it affects all of the infrastructures also. And I think that we're just not aware, or maybe we just hide our head in the sand, that don't want to be aware that this has huge, huge implications to basically mankind. So with that, I think it's really important, the work that MEF and CyberRatings are doing together in the SASE certification. So talk to us about what are the opportunities and challenges you see in SASE, and what is SASE? Describe SASE first for our listeners, and maybe just describe the opportunities and challenges you see.
Sure. So, we're using the term SASE. I believe the term was coined by Gartner, and, it covers the technology space for secure access and services edge, which essentially integrates the combination of, SD-WAN as a service in combination with security services like firewalling, secure web gateway, CASB, also with technology elements like zero trust, right? Authentication for everything, no implied trust, and basically authentication for all resources at a granular level. And those technologies in combination are deployed to allow enterprise users easier access to both internal resources and public resources on the internet, but through these security services, so that everything is screened and policy is applied accordingly. So the opportunities there is that, this consolidation of these capabilities into the SASE space being provided by SASE technology vendors can greatly improve security posture theoretically, right? Basically, conceptually, by having these technologies better aligned and integrated, enterprises could potentially benefit from a unified approach to their security by maintaining more consistent policies deployed and enforced across remote users, branches, and cloud applications without having a complexity of multi-point or multi-vendor solutions. And so that operational simplicity in SASE is a huge advantage potentially for improving security. That being said, not all SASE solutions are created equal. Just like all security technology products and offerings are not created equal. In our testing, we've seen that some solutions and products tend to perform better than others, depending on the approach that a particular vendor takes or doesn't take in order to deliver the technology. But in theory, if everything is done correctly, there could be a tremendous operational efficiency in combination with improved security posture for enterprise custom end user customers and service providers, while reducing operational overhead and simplifying their procurement and management, if you will, of their access technologies. Some of the challenges we're seeing is that in the SASE space, because it's a very rapidly evolving space, relatively new, there's a couple of challenges there. One is there tends to be some vendor and technology fragmentation. Some vendors are very well integrated vertically across the SASE stack, from SD-WAN to SSE to Zero Trust, while other vendors take a less integrated approach and tend to have a collection of loosely connected technologies. And as they try to integrate them more tightly towards a more integrated solution longer term, right? So there's a slight different approach and slight different result depending on the vendor. We're also seeing a challenge for enterprises to trust these technologies because it is a paradigm shift going from infrastructure that maybe an enterprise previously managed and controlled to one that is completely outsourced and managed and controlled by a SASE vendor as a cloud solution. There's this period where trust has to build. Enterprises have to believe that they can trust a third-party solution and environment to the degree of meeting their requirements and relinquish control of that environment to that vendor. So that trust has to be built. And that's where a lot of our testing comes in. The testing that we do in combination with MEF for the SASE certification is to help foster that building of that trust and help accelerate the adoption of these new technologies by helping enterprises understand the risk factors introduced or the lack thereof, the reduced amount of risk in using a certified solution versus a non-certified solution.
Yeah, and I think what we want to talk about, though, is SASE is a cloud technology. So basically, these functions, the security functions, sit in a cloud, and they are positioned near the edges of where the users are. So if they're globally, they're positioned as close as possible to where the users could be in every country, in every city, because it has to be, because all the packets go into that security cloud, if you want to think of it as SASE cloud, at the edge somewhere, and basically get scrubbed, and then it either goes out to wherever the destinations are or go back to the provider to go out to the destination. So latency plays a very critical role, but the good news is that users or subscribers can access that SASE cloud from anywhere and don't have to go back to a corporate site to do that all this stuff. So do I have that correct?
That's correct. That's one of the great things about SASE is that when deployed correctly, it can be deployed in a very distributed manner as a cloud service with points of presence and points of access closest to the user, so that traffic can be optimized instead of having to provide long haul centralized points of enforcement, if you will, for policy. So that's one of the things that those SASE vendors are taking on that greatly reduces the overhead for an enterprise, is the ability to consistently intake policy and apply it globally at a global scale at the edge around its entire network footprint, right? The SASE vendor's network footprint, so that anybody accessing the service or entering the SASE environment from anywhere in the world can have that policy consistently applied. That's no small feat. It's something that's been challenging for enterprises to implement themselves, and SASE solves that problem.
Yeah, and so the CyberRatings testing, which delivers off our MEF SASE standardization or certification. So I think there's some really, really important testing that goes on there, right? Can you articulate for our listeners what you're testing? So, for example, I know you do all kinds of threats, which are exploits, malware, evasions. Can you explain what you're testing in these areas of threats?
Sure. Yes. So let's discuss that in the context of security effectiveness, right? So in the SASE space, one of the critical capabilities is the SSE, or the Security Services Edge, the ability to provide security and policy services to traffic that's entering the SASE space, or in the SASE service, if you will. In that particular context, we test the security effectiveness of the SSE component in the SASE stack. And what that means is we actually take an adversarial approach to testing the solution or the product and the technology by subjecting it to actual samples. And we use various threat samples, if you will, to test the effectiveness of the inspection engine, firewall engine, the overall security engines that are used to deliver that service. We do this by actually sending actual wild malware samples through the system. So when we say we test against malware downloads, we're actually using what we like to call inoculated malware. So it's malware that's we've taken a sample of curated malware, we're sending it through the SASE system. There's no execution of that malware. So the malware is downloaded between our test systems using the SASE as the device under test or the environment under test. We emulate a client that goes out across the SASE service through to the internet and pulls down a malware sample from our servers in our threat cloud. And then we measure whether that malware is actually detected and blocked or allowed through by the service. And that provides us a real world metric by passing thousands of these samples through, it provides us a real-world understanding of the effectiveness of that platform in blocking malware. And we'll do the same for other areas of threat protection, like exploits. So we have an extensive library of curated exploit samples, and we'll send samples of various exploits from the CVE database that have been realized by our researchers, and we'll send it through the SASE service again to detect whether it's to basically analyze whether it's been detected and blocked or whether it's been allowed through, allowing us to thereby measure its effectiveness. So the difference in the way we test is that we are using actual threat samples to measure the effectiveness of the engines providing the service in a very adversarial approach. When we do this testing, we don't tell the vendors what we'll be sending. We give them the nature of what we'll be sending, but we don't give them the exact answers to what we'll be sending. So we get this really unbiased, unprepared look at how effective their platform truly is.
So can you just explain for our listeners what malware exploits and evasions are? Because I don't think many people understand that.
Sure. Yeah, that's a great point. So let's go into a little bit of that and differentiate them. Malware is typically what you would find like a piece of content, like a file. So it's typically something you would download or maybe embedded in something you would download and then is executed locally. This is typically an attack vector that's used on a client endpoint or an end user. So for example, I received that email attachment, and in that email attachment is an executable or script that is going to install a backdoor on my PC. That's a typical example of malware, right? It's a piece of software that someone downloads and accidentally, inadvertently executes, and it actually performs actions or does malicious activity on their endpoint, their laptop or device. That's a sample of malware. An exploit itself is more of a vulnerability or a flaw in a piece of software that can be exploited or leveraged to gain escalated access or greater privileges and control over that application or system. And an example of that would be, for example, like a Apache web server, right? If you're using an Apache HTTP web server, or you're using another type of backend application like a database server, there may be a flaw or a bug in that software that's been discovered in which someone could exploit that flaw or bug to inject additional data to cause that application to execute something that wasn't intended, and potentially with an escalated privilege, which allows someone to take control or further control of that particular application, platform, or server. And that's an example of exploits. And exploits are typically well documented. As they're discovered, they're registered in the CVE database. Anyone can see the database. It's public information. You go to cve.org, which will list the exploits that have been discovered by researchers and reported in. And you can see the nature of them. And generally, people will use that database to track them and track how vendors are doing against, addressing those particular exploits. In our testing, we'll take the exploit information, which doesn't have implementation of the exploit. It just gives you a description of what is being attacked and how it's being attacked. And our researchers will actually build exploits to be able to leverage that CVE or that known exploit so that we can create a version that would be detectable by a security engine. So we'll actually create an implementation of it that we can send as a sample without actually performing the malicious acts, but send that sample of code through so that we can actually test these engines and these products and services and devices.
So what's the quantity? So I believe in the malware, I think we're talking millions, right? So you can't possibly test all millions. And then what in exploits and evasions, how they're in tens of thousands?
That's correct. So malware, if you look at the wild malware database, people can actually search this up out there. There are several malware databases. Collectively, there's over 1 million to 1.5 million active malware samples out in the wild. We don't test against all 1 million. It's simply a time issue. If we ran all of those samples, it would take a long time to test them. So what we actually do is we curate samples out of that in the thousands. So we'll use maybe a couple thousand, anywhere between 2,000 and 5,000 samples of malware, selected carefully. So they're curated. We don't just take them randomly. They're curated around the test case, the scenario, and the current conditions of the threat landscape. So we'll take things that are currently being used out there. We try to, we'll basically cut out stuff that's too old or everyone knows extremely well. We'll go for something more recent. We'll pick based on the applications and the use cases that we're testing for. So if we're simulating end users, we'll focus on applications end users would leverage or file types end users would leverage and focus our malware on that as we curate it down to the several thousand samples. For exploits, we do the same thing. We look at the test use cases. Are we protecting the data center? Are we protecting enterprise applications? What types of applications? And we'll curate the exploit samples down to a couple thousand again, instead of the the potentially 250,000 exploits that are in the CVE database. We'll bring that down to a couple thousand by looking at the test case, the use cases, what the potential targets are, and curating them down to focus on those, so that we better align the threats with the deployment scenario and the real world use cases of the technology solution or product that we're testing.
But I think you do more than just testing that now. You also check to see how well it's classified the applications, because if you look at applications, whether it has to go through a security function, if it doesn't understand how to classify that application, and then it won't know what to do. So classification is important, performance. Can you talk about those kind of things too? Because there's so much you're doing.
Yeah, so on the SASE side, one big component of it is SD-WAN, right? So the ability to provide connectivity and application assurance and protection is a big part of the overall SASE stack. So we talked about security in the context of SSE, which is just one part of the SASE stack, but there's also the SD-WAN component. The SD-WAN component is more focused on ensuring that traffic is properly delivered reliably and consistently to meet the requirements of the application profiles being sent across that connection. And a good example of that is if I'm doing video conferencing or voice, right? If I'm trying to communicate with real-time traffic, it's inherently critical that the component of SD-WAN can classify my traffic, understand what type of traffic it is, prioritize it accordingly, and handle it to meet the quality of service necessary to ensure a consistent and acceptable user experience. And so we have to test that. As part of the testing of the SASE stack, we have to test SD-WAN and its capabilities to ensure application performance and consistency. And in order to do that, we'll pass traffic of the types that enterprises would be using, whether it's web traffic, email traffic, file transfer traffic, in combination with video traffic and voice traffic, through the SD-WAN component of a SASE stack. And then we'll actually artificially introduce network failures, network latency, packet loss, packet reordering to see how the SD-WAN component of that SASE stack would handle that. And so we're able to measure the performance of the SD-WAN component in the SASE offering in terms of how it would perform in real-world scenarios, real-world applications, seeing real-world potential impacts that might be encountered by an enterprise.
And what about the idea of authentication authorization policies like zero trust?
Yeah, so the other pillar of SASE is zero trust, and I'm glad you brought that up. It's a great shift in terms of perspective for security to move from zero trust from traditional authentication methods, right? So in the past, when people would want to connect to resources, first thing they would typically do in the past was connect to the network via a VPN. The problem with that model is that once the VPN was connected, everything was inherently trusted after that, and the user was given sort of wider range access within the environment once they were inherently connected at a trust level. So the trust was at a connection level. In a zero trust environment, the authentication authorization paradigm is shifted to become more granular, such that the user themselves, and in combination with the resource they're trying to access, becomes one of the factors used in that authorization equation, right? So when a user authenticates, in the past, the authorization would be you could connect to the network, now you can go access resources. In a zero trust environment, it's much more granular. Based on who you are and what your authorization policies are for the particular resource you're trying to access, the policy will be determined based on the authorization. And that gives you greater granular control of policy with respect to a particular user. And the key to that is being able to not just set that policy at that granular level, but maintain it consistently throughout the environment across a global footprint, which is where SASE vendors bring tremendous value to that capability. For anyone who's ever had to do that in an enterprise network, trying to maintain global level consistency and policy for users at that granular level anywhere in the world is not a small feat, right? So SASE can greatly reduce the complexity of being able to maintain that consistency of security and policy enforcement in an enterprise environment.
But context plays an important point of view also. So maybe the policy is only good for a certain time of day or where they're located. Do you test for that too?
Yes, we do test for time of day. There are many dimensions you can test for. So you can test for based on identity. You can test based on the resource they're trying to access, categories of resources. So the great thing about zero trust, the great thing about what a lot of these SASE providers are offering is they can provide very granular control and policy, including not just identity and authorization for a particular resource, but time of day, location, where you are geographically in the world, whether you're in an office or outside, whether you're within an organization's property or outside of their organization's property. So there are many dimensions, and we do test for all of those. We simulate remote users, whether they're mobile, remote users from branches, remote users on the internet, as well as users within the enterprise. So we test for different use cases, different scenarios, different policy perspectives to ensure that the offering from that SASE vendor is able to provide that level of granularity in policy creation and enforcement.
So Ian, as you wrap up any last thoughts? I mean, this is quite impressive amount of testing and certification that gets done. A lot of vendors, providers, they should be all jumping in. So, really the call to action is get certified. It's the only really certification that does cybersecurity testing like this from a standards body with MEF in the world. Is that correct?
Yes, I agree. And that's exactly what the value of the MEF SASE certification program is, right? In having MEF and CyberRatings working together, what we're trying to do is create a benchmark, if you will, in the industry of a standard of care, meaning that anything that is MEF SASE certified comes with it a level of assurance that its performance and security effectiveness meets the levels required to be usable by the enterprise and by service providers with confidence. Right, and this goes beyond just the assurances given by a particular vendor and comes down to evidence-based assurance. When a vendor tells you they're selling you a particular service, you can assume that it works and that you're protected, or you can know that it works and that you're protected. And the difference between just assuming it and knowing it is whether there's evidentiary data from testing behind it to back that claim up. And that's what the MEF SASE certification brings to the table, is that any product or solution technology offered by a vendor that's MEF SASE certified has been tested to meet the criteria required to actually perform to the levels expected by either end users, service providers, or even the vendors developing their products.
So can I be bold to say that the vendors and providers that have tested with us are really providing a service to the society, saying, look, I'm willing to be transparent and tell you how I fare, correct?
100%.
For the vendors and providers that don't want to do it, is that kind of a point of view that they're not being responsible in some ways? Now, I'm not trying to bash anybody. I'm just I think we've got this program out. It's really, really powerful. It's important. And I'm kind of wondering, I know we have quite a lot of good vendors and providers already lined up and certified, but there's so many vendors and providers out there. I guess it's maybe they haven't heard about it. How do we get that to the market and message the market? So
to answer your first question, yes. I think it's pretty obvious that any vendor that's willing to step up and have their product and technology scrutinized is standing behind the premise of transparency, and that they stand behind building a quality product that their customers can stand behind. There could be any number of reasons a vendor isn't certified, but you would have to wonder, if they have confidence in their product and does perform as expected, why wouldn't they get certified? The barrier to certification is really relatively low for any of these vendors, right? So you would think that, trying to step up, support transparency, provide evidence that your product works as expected, to help foster that assurance and trust with your customers and vendors and channel partners would be something everyone would want. I think maybe if it is an awareness problem, really the best way to help foster that is for service providers that are considering using these technologies, or end users that are considering using technologies, to demand that level of transparency and assurance from their solution vendors by encouraging them to get certified, so that they can have that stamp of confidence behind the level of performance of their product.
Yeah, so true. Otherwise, they're going to have to test their own, right? If you're an enterprise and you're buying a service, if you don't, they're not being tested by a third party like us, MEF CyberRatings, with the certification, then they're going to have to test their own.
They would.
That's expensive.
Yeah. It can be very expensive. The overhead to do so, the tooling, understanding it, the expertise to get it done effectively is not insignificant. Which is we've spent literally decades building up this expertise, tooling capability, at CyberRatings, and so we have all this experience that customers, partners, and vendors can leverage. But you're right. If they don't, if it isn't certified, then they have to wonder, do I have to test it myself? And do I have to incur the cost of validating this technology to make it acceptable? Because one thing we're seeing in the industry is that governance is becoming a big part of this, right? Supply chain auditing, understanding that the solutions you're purchasing are effective, is sort of the next mark of governance. It's no longer enough to say that you're complying with security requirements or regulations by just having something. But what are you doing? What are you doing in terms of due diligence as the next step to ensure that what you're buying and deploying actually protects you and works to actually effectively reduce your risk, right? And that's coming from all stakeholders, whether they're internal stakeholder organizations or external stakeholder organizations.
Yeah, so spot on. I would think that if I'm going to buy a service, I have to make sure it's secure. So either I have to test it, or I have to have some third-party certifications tested, or I have to take their word for it. Now, taking the word of a vendor or provider, is that good enough? Is that what's going on? People are just accepting that? Or because the word of the vendor has a brand behind them, they've been used for maybe a decade, and people just say they got to be secure. Is that how it works?
I think there's some of that going on. I would hope that most people don't, just blindly take the word of somebody selling them something. It's kind of like the old adage of, you don't want to ask your barber if you need a haircut, right? I think there's a certain level of due diligence that every organization should impose on all of their suppliers in order to assure themselves that they're meeting the minimum bar of due diligence to know about the effectiveness of the technologies they're buying. And I think that there's a risk in not doing so. I think that as everyone is witnessing, the increase of the cyber threat landscape and its outsized financial impact, the bar for negligence is going to change. And simply buying technology and saying, well, the vendor told me it was effective and I didn't know, and we got breached, it isn't going to be a good enough excuse for stakeholders going forward.
Yeah, thank you. And with that, we've gone quite over, but it's been a fascinating topic. And thank you, Ian, for sharing all this background and how it's tested and what are all these, what's malware and exploits and so on. So I really appreciate it. I think that our listeners and audience will be very appreciative of all this information. So thank you.
Great. Thanks, Pascal. Thanks for having us. It's been a pleasure.
Thanks for joining us for Executives at the Edge. Don't miss an episode. Subscribe today. Share online and review. Find all our episodes on your favorite podcast platform and at MEF.net.